guys, hopefully everything's going well at home. So we're gonna do section 8 this week, 5.8. I have this broken up into 2 parts, but I'm gonna go ahead and do just one video for the whole thing. When we get to the second part of the lesson with the second section of homework, I'll let you know, so it'll be up to you guys if you want to stop the video, do that part of the homework, and then continue on, or if you just want to watch the whole video, get it all done with, and then do all the homework together. Either way is up to you, and just let me know if you guys have any questions. Go ahead and get your, as we're doing the videos, go ahead and get your, that sheet that I gave you guys a few weeks back that had a bunch of derivative formulas and integral formulas. I'll kind of reference that as we're going. This first section is going to be looking at derivatives of our inverse trig functions. So arcsine, arccosine, arctangent, arccotangent, arcsecant, and arccosecant. And that's going to be, if you're looking at that sheet, it's number 19 through 24 on the derivative parts. Okay, so when we get to doing the derivative stuff, that's what we're going to do. The first part of this lesson, though, is just to do a little bit of pre-calc review, kind of like we've been doing throughout these sections in Chapter 5, where we always just do like a little bit of a review on the functions themselves, the stuff we learned about the functions in pre-calculus, before we jump into the derivatives and integral side of things. And so this first part's just looking at solving inverse trig functions. And just a couple reminders. If you're looking at what inverse trig functions are supposed to equal, remember that their ranges can be somewhat limited. That's on page 380 in your textbook. Basically, just a reminder, your arcsine and arctangent have to equal, can only equal angles between negative pi over 2 to positive pi over 2. So that's angles in the 4th quadrant and angles in the 1st quadrant. But if you're picking angles out of the 4th quadrant, you have to use the negative of the angles, not the positive angles. So, for example, you wouldn't use the angle, gotta think of one off the top of my head now. You wouldn't use the angle 11 pi over 6. You would use negative pi over 6. And then remember that arccosine has to be between 0 and 2 pi. Or excuse me, 0 and pi. So that's the 1st and 2nd quadrant. And that one, you don't have to worry about any negative angles. But for arcsine and arctangent, you do. But we're not going to do a lot with that, but just kind of keep that in mind. Okay, so looking at solving this first equation, remember that our inverse trig functions are our way of solving they're our way of undoing trig functions. So for solving an inverse trig function, anytime we're solving equations, we always try and use those inverse operations to counteract, to work backwards. So if I'm taking the arctangent of something and it's supposed to equal 1.5, I can use that inverse function, which would be tangent, because tangent and arctangent would be inverses of each other. So this is the same thing as saying tangent of 1.5 equals 2x minus 3. Now, depending on what you have right here, if you can use your unit circle, go ahead and do so. So you're trying to take the tangent of 1.5. If you can get exact by using your unit circle, great. But you'll notice in this particular case, 1.5 is not an angle on our unit circle. And so if that's the case, then just type it into your calculator. Now, remember that pretty much across the board in calculus, we want to make sure we're in radian mode. So make sure you're in radian mode before you do anything with your trig functions. And so it's going to be tangent of 1.5. That's, oh, what was it again? 14.1. 2x minus 3, then plus 3. That's 17.1 divided by 2. And x equals 17.1 divided by 2. Let me grab that calculator again. 17.1 divided by 2 is 8.6. Now, one thing I do want to point out before I get too far ahead of myself, as I'm doing these days, since I'm not in the classroom and kind of watching you guys, I'm not necessarily going to be going at the same pace that I would for class. So feel free to pause at any time you want. Nice thing about videos as opposed to class is, while in class you can always ask me to repeat myself, but with the video you don't even have to ask. You can just rewind or pause. So remember that that's one nice thing about doing it this way. As opposed to in class, it's a little bit easier to speed up or slow down the pace, whatever you guys need. All right, next problem. All right, given that y is equal to the arcsecant of square root of 5 over 2, find tangent of y. So when you're looking at a problem like this, first thing that you need to address, or first thing that you need to recognize, is what exactly do our inverse functions tell us? And thinking back to pre-calculus, our inverse functions help us to find angles. So when we use inverse trig functions, it's because we are looking for an angle, and we want to find that angle. So one thing that we know right off the bat is that y should be some angle. Okay, and even more specifically, our inverse trig functions help us find angles in right triangles. So one thing that right off the bat we can say is that right now we don't know the size of y, but I do know that it's an angle inside of a right triangle. So I'm going to go ahead and draw that. Okay, so I've got an angle inside a right triangle. Okay, and y is that angle somewhere. Okay, and so y is an angle in there in my right triangle. And when I take the arcsecant of square root of 5 over 2, that's supposed to tell me that angle. Okay, another way you could think about that, thinking back to how we just solved the previous problem, this means that secant of y equals square root of 5 over 2. All right, now you could type this in your calculator. We don't want to. Okay, we're not going to type this into our calculator. Okay, the problem with the calculator is it's going to give us a decimal answer, which if we can't get precise, that's one thing. But whenever we can, we like to try and be precise. So whenever possible, we want to try and be precise. Okay, and what I'm going to be doing here is to try and find the tangent of this angle. So my overall goal is to find the tangent of y. And in order to find the tangent of y, think about how we find tangent. Tangent is the opposite divided by the adjacent. So if I want to find the tangent of y, that's what I'm asked to do. I need to figure out the opposite side and divide it by the adjacent side of this triangle up here. Okay, so I'm looking at that triangle and I need to find the opposite side divided by the adjacent side. That's how I'm going to find the tangent of that angle. Okay. Now, I was given that the secant of y, I was given that y is equal to the arcsecant of square root of 5 over 2. But I was able to decide that that meant that the secant of y is equal to the square root of 5 over 2. Now, that can actually be quite helpful because racking our brains, thinking back to pre-calculus, secant of an angle, remembering secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So that means that this has to be the hypotenuse divided by the adjacent. Okay, so that tells me that my adjacent side is 2. Okay, so that's helpful. The adjacent side is 2. It doesn't tell me, however, what my opposite side is, which is what I need to find my tangent, but I do know my hypotenuse is square root of 5. Okay, that information right there is actually enough to figure out what that opposite side is. Because it's a right triangle, I know 2 sides. Hopefully, what's popping in your head right now is Pythagorean theorem. So I can find that adjacent, or that opposite side. We'll call that opposite. I don't want to call that adjacent. I don't want to call that A. Or I'll just call it B. For the A squared plus B squared. Don't want to call it A because that might get confused with the adjacent. So 2 squared plus B squared equals square root of 5 squared. That's 4 plus B squared equals 5, which means B squared is whoops. Oh, no, I did that right. Sorry. Equals, did it right before, but now I'm getting wrong. Okay, so subtract the 4, so that's going to give you B squared equals 1, which makes the B equal 1. Square root of 1 is 1. And so that gives us tangent being 1. Now, one thing you could ask yourself is right here, when we square root a squared, we have to do a plus or minus. Okay? And so when we square root a squared, we usually have to do a plus or minus. So I'm just going to put kind of plus or minus question mark there. And so how do we know whether it's supposed to be a positive 1 or a negative 1? And so this is where, though, what I was talking about at the very beginning is arcsecant is the reciprocal of arc cosine. And we know that arc cosine can only be talking about angles in the first quadrant and the second quadrant. Okay, so we can only be looking at angles in the first quadrant and the second quadrant by definition of arc cosine. Okay, so because arcsecant is the reciprocal of that, same rule applies. You can only be looking in the first quadrant or the second quadrant. Now, because what we're taking the arcsecant of is positive, that has to be in the first quadrant. Okay, and if it's in the first quadrant, everything is positive. So we can determine that the 1 has to be a positive 1. Okay, so we know that 1/2 is good there. Okay, so this is it for the first half. So again, it's up to you guys if you want to pause it here. When I stick it on YouTube, I'm going to have to stop it here anyway. So actually, I take it back. I'm just going to stop it here because I'll have to when I upload it to the YouTube playlist so that you guys can access it there. So I'll stop it here and then I will jump into the second part in the next video.